You guys know what a polygon is?
No.
Oh,
Just take a guess. Anything's
Anything's
got what?
It's an angle with 5 sides.
No, triangle's a polygon.
No way. It's just something that has an angle. Something that has an
Yeah,
angle.
okay. Alright, so here's the thing, guys. If you get the idea, it's shape, it's made up of straight lines, and it's completely enclosed, you're fine. Okay? If you do if you want to write out more of a formal definition for it, this is how it would go. Plane figure just means it's flat. We're not three-dimensional. So this is a flat shape. The first part saying it's formed by 3 or more segments is essentially me saying it's got to have 3 sides with nothing curved in it. They're all going to be straight lines. Then the other part that says each side intersects exactly 2 other sides means it's completely enclosed. There's no gaps. There's nothing missing from it. Like there isn't a space between segments. So all you're looking at really is 3 or more sides, nothing curved, and no gaps in it. Okay? All right. Now, for every polygon you run into, make sure that you remember the points where the 2 sides come together. That's your vertices. Okay, so each point is considered a vertex, and however many sides they have is going to be equal to the same number of vertices it has. When you name these things, you name them based on the letters. What? Yes, we name them by race. So like this one here, I would say the name for that one would be like PQRST. There's no symbol in front. The only ones we have symbols for are going to be triangles and parallelograms. The order of these doesn't matter as long as you're going in a circular path around it, like either clockwise or counterclockwise. So I could also name that, like if I started with S, I could name it SRQPT, because that would still be connecting them in a kind of like circular pattern. So you might see a problem that says, give me 2 names for this, and the 2 names is just you picking a different starting letter and then going around it. Like these are 2 different names. Don't get the names mixed up with classifications, because the classifications would be me saying like what type of polygon is that.
So both of those would be right?
Yeah. Okay, do you guys know like what type this is? So what? Say it louder. Pentagon. Okay, so here's what I'm pointing out now. This right here, this is not the name. When they say name it, they're looking for this. This right here would be your classification. Since your polygons start with 3 sides, I think everyone should be familiar with 3 sides being a triangle. No problems there. The next one up would be 4 sides, what's a 4-sided polygon called, do you know?
Square?
Not a square, no.
A rectangular
Parallelogram.
Nope.
Trapezoid.
What?
Quadrilateral.
No, quadrilateral.
Quadrilateral. Yes.
The other names are too specific. This is just general. And then 5 sides, of course, we already had up there. That would be your pentagon. After that, you got 6 sides. You know what that is? Hexagon. What about 7?
Octagon.
Heptagon.
Octagon. I mean
Heptagon.
Sevenagon.
Heptagon. Octagon would be your next one. That's 8.
Nonagon.
Nonagon.
Polyhedron.
10 sides would be your decagon. And then the only other one you guys have to know by name is 12. Okay? 12 is dodecagon. These are the ones that you're expected to know by name. Alright, if you get that down, guys, you're fine. The convex ones all point out. Concave one has to have a part of it that goes in.
Just things your guts are concave.
So like the one that is on the
I bet the concave one's
looking at it left would be the concave, and the other one would be convex. Okay? So as long as you see, and guys, it can be like the tiniest portion going inside, and it's technically considered concave. So like, even if they did something,
Green markers.
Don't use your hands. That wasn't smart.
When the green markers are
no, the green markers are just horrible.
It's not religion to do that.
To do what?
To just to do whatever you just did. To do whatever you did. Yeah. It's I can only say this.
I'll give you this like
Like that right there, guys?
What?
Wait.
That was like a text bubble.
Hey, just so you know, like this here would be considered concave because you've got this little portion cutting inside of it.
Oh.
it looks like
As long as you have one little tiny portion going inside, it's considered concave.
That was a portion out.
And this would be, what is it? 1, 2, 3, 4, 5, 6, 7. So this would be a concave heptagon.
it's technically not a shape.
Okay?
So heroic.
Why is it not a shape?
It doesn't look like it looks like an upside down like chat box.
Just because it doesn't look like something, you think it's not a shape? This doesn't make any sense. Okay. All right. So again, at its like heart, guys, it's concave is just going in. Concave is or convex is everything going out. Okay. All right. Next bit. These are the last bit of classifications. This would only be for specific situations. Equilateral. We've already dealt with before triangles. With other polygons, it means the same thing. Equilateral always means that all the sides are the same. Okay? If you have a shape that has all the angles exactly the same, it's called equiangular. And they don't have to go hand in hand. Like triangles, if it's equilateral, it's also equiangular. Like all the angles were the same, but that's not the case for every other polygon. But if you do have a shape where both of these things are happening at the same time, like it's equilateral and it's equiangular, then it's considered regular. So when they use the term regular, they're telling you that everything's congruent. Like all the sides and all the angles are congruent to each other. So the first thing you would approach is the sum of the interior angles, which we've done this with triangles because the sum of the interior angles of a triangle add up to 180. Okay? And that's still not changing. But the fact that triangles add up to 180 is how all the other ones are formed. So like if you move to 8 sides and they say what do all the angles add up to, you can use a nice little formula based on triangles to figure it out. And the way it works is like the formula that's going to be up there, the way it's formed is, let's say, what did I say, 8 sides. So if we had an octagon, blah, blah. All right, the way this thing is, the way the formula works is it basically takes each shape and breaks it up into triangles, but the triangles all come from the exact same vertex. So if I took this vertex here, I'll label it, just say that's where I'm starting, and I created triangles inside this shape, I would be able to create I would be able to create 1, 2, 3, 4, 5, 6 triangles. Okay? So, and I know each triangle adds up to how many degrees?
180.
180. So there's 180 there, and there. So that means every octagon is technically broken up into 6 triangles, all of 180 degrees. So I know like an octagon, like the interior angles of an octagon add up to 6 times 180. Because there are 6 triangles and each triangle is 180 degrees.
Which is 1080.
Which is 1080 degrees.
You're welcome.
So that means like this angle plus this one plus this one plus whatever, it's gone. And again, this number right here would be if these triangles didn't exist. I'm just showing you where this whole formula thing is stemmed from. Okay? Now, the way you get this number is you always take the number of sides that the shape is made up of. Like an octagon is made up of 8 sides. So you do 8 minus 2. So you're always taking number of sides and you're subtracting 2 from it to get the number of triangles. And you take the number of triangles, multiply it by 180. So a basic problem would just be, hey, they'll say find the sum of the interior angles of and it has to be a convex polygon. The whole trick would you just making sure you know how many sides each thing has. And then plugging it into the n minus 2 times 180 thing. 17, anything, guys, anything that's not 12, like that's not on that list that I said you had to know. So 3 through 10 and then 12. Anything beyond that, you just put the number of sides and you put gon at the end of it. So like 17 gon has 17 sides. Okay.
LOL.
Alright, so can someone do this for me? Nonagon has how many sides?
9.
So I need 9 minus 2 times 180.
That's
7 times.
986. Just kidding. That would be awesome if I had it.
That would be amazing.
Sorry, I don't know that. It's not my religion.
Wait, what?
Oh wait, I got
160.
mine.
1260.
1260. There you go, the first one. Alright, and then for the second one again, this would be 17 minus 2 times 180. So 15 times 180.
2,700.
There you go, 2000.
Woo! Sarah got it first.
Alright, now look, this by itself isn't that bad. The way you guys would have to use it is you'd have problems like this. Okay? And we'll start with 4 sides because 4 sides is another thing that you should always know how many degrees it adds up to. Okay, so here's the thing. This formula that was up there gets you the sum of the angles. So from now on, if they've got variables and these variables are somehow attached to angles, you're probably going to have to do that first to get what they should add up to. Because the idea is going to be you're going to add all of them together, but the only way you can figure out what they should equal when you add them all together is to use this formula. So this formula here will tell you what they should equal when they add together.
Oh my god.
Okay? So a 4-sided figure would be 4 minus 2 times 180, which is 360. That should be something that you definitely know from now on. Like if there's 4 sides, it's 360. Like a 3-sided figure being 180 and a 4-sided being 360 are the two you definitely need to know without having to do the formula. Okay? So all this here, again, all this does, this part right here, is it tells me what to set it equal to after I add them up. So if I take those 4 angles and add them up, that'll give me 17x.
Yep.
Now how many is there?
No, I'm just feeling
30, what's that? 3? Is that positive 3? If I combine all my like terms?
Sure.
Someone do it for me. I'm adding all these up. So this plus this plus this plus this.
9 plus 8, 17. That's right. Okay, then it's 34, 15, 49, 49 plus 15. That's 14,
3,
49,
okay.
59, 59.
What are you going on?
What are you doing? That's a positive. These are negatives.
I don't know.
I got 3.
You 15 and 15 is 30.
Oh.
34 minus 30 is 4. Then you take away another 1.
Yeah, that's what I had.
I know, you were right there. Okay. Alright, so what's 360 minus 3?
21.
357, and then what'd you say it was?
21.
21? There you go. Alright, so look, what I'm saying is from now on, if you've got a problem where you're trying to find a variable and they give you like something at every angle, do this first to get the sum of it. Okay? Alright, say, here's the thing. First thing, don't start adding the angles up yet because you know what the heck to set it equal to. Alright? First thing you want to do is that, because that's going to tell you what to set it equal to. 5 sides there, yes?
Yeah. 3.
That should be
540.
540. So I got, you tell me 21x, and then what's the number with it?
15.
15?
You wrong, girl. Why don't you try and...
No,
you good.
no, they're
She good. No, it's 30 plus...
30 minus 20 plus 5.
30 minus 1.
Guys, hey, 540 minus 15 is what? Quick!
530. 525.
And divided by 21 is?
0.
0.
25.
25.
25, probably.
Do this first.
Wait.
Okay? Don't do anything else on the problem until you do that first. Guys, with this, the exterior angles, exterior angles, you have to remember, they're always formed by just extending the sides out. So, like if I had this shape here, the pentagon, 1, 2, 3, 4, and 5 would all add up to 360. Always. This, guys, does not matter how many sides you have. You can have 100 sides and it's still going to add up to 360. Again, this, I don't have it up there, but this is only for convex polygons. Okay? If it's concave, then you just move on. But all the problems you do will be convex ones. All right, so just make sure you have a note saying exterior angles always add up to 360. All right, and then before you get classwork, the other thing will be with regular polygons, as long as you know the idea that regular means all the angles are the same, you shouldn't necessarily need a formula for this. Some people like to write it down. If I gave you a problem and said, tell me the measure of one interior angle of a regular like heptagon or something. That means that you have 7 angles that are identical to each other. You can use the formula that was already up there to figure out what they should add up to. So you can just take the formula that they add up to and then divide it by 7, because there's 7 angles. The number of angles and number of sides will always be equal. So if I told you it's an octagon, there's 8 angles. Decagon, there's 10. Okay? If you want to write like an actual formula down, that's what it would be. But that's just what we had before divided by the number of sides.
Is that one?
If you write this down, make sure you take a big note saying like this is for one angle. Like stress one angle of a regular polygon. So you don't get this mixed up with the sum of the angles, because that'd be a different thing. What were you gonna say? Okay. And then if you wanted it for the exterior, it would just be 360 over the number of sides. Shape that you guys will write out, well, the only other polygon that actually has like a little symbol they'll put in front of it. So if you ever see like the 4 letters and then they put something like with a 4-sided figure in front, they're telling you it's a parallelogram. Which would in turn mean if this thing is a parallelogram, then you're going to have a list of properties that automatically apply to it. Okay? And parallelograms are fairly easy to work with. Actually, it would have made some of the proofs easier last chapter, or the chapter 4, if we had these properties ahead of time. Yeah.
The parallelogram, that's more that shape, or could they be like a square?
Square is a specific type of
They
parallelogram.
could be like all 90-degree angles.
Yeah, that's a parallelogram. Okay. This is just the most general one you could write. All right, so the properties that exist, guys, there are, I think there's 4 that we got to write out today. The first one is the definition of it, the fact that they're parallel. This also I listed as a property because of all the stuff we did like in chapter 3 with alternate interior angles, same side interior angles, and that kind of stuff. That still applies here. Okay, so as soon as parallel lines come up, that means that everything we did in that chapter still applies. Just because I'm talking about a 4-sided figure now doesn't mean that you ignore everything from the past. Okay? The rest, there's 2 that deal with things being congruent, and the other one is with adding up to 180. Okay? So you got opposite sides and opposite angles are being congruent to each other. Opposite meaning like they're directly across from each other. Okay? Then you got the diagonals bisecting each other. Actually, there's 5, sorry. And then consecutive angles are supplementary. So that if I drew a picture out, no listen, but I also want to draw a picture, so I went through them quick. Oh well, that's horrible. On the what? Okay, so if you have a parallelogram, essentially everything you can mark off, if I told you flat out that was a parallelogram, would be that the sides are parallel. You can put congruent marks on the opposite sides. So the top and bottom, left and right ones are going to be equal. Opposite angles would be the ones that are like diagonally across from each other. So A and C would be the same.
E and B.
And D and B. The diagonals bisecting each other. That would be a diagonal. A diagonal, guys, just goes from one vertex to another, but it has to pass through the actual shape. That's by definition what a diagonal is. And those apply to any polygons. And this would be also. When it says it bisects each other, that just means that like this segment is split in half, and this segment right here is also split in half. Okay, it doesn't mean that these two are equal to each other. It just means that it takes each one and it bisects.
Can they all be equal to each other?
If it's a rectangular square, yes.
That doesn't
It has to be a very specific thing.
Which
What?
one is it?
A square is a parallelogram,
Squares are rectangle.
and a square is also a rectangle, so it multiplies it.
Wait, but I thought a rectangle, not all sides are congruent.
That's right. A rectangle is not a square.
But a square can be a rectangle.
Yes.
Jesus Christ. I went over this. Sorry.
Okay.
All right, the only thing I didn't write up there, guys, consecutive angles just means like if you're going around the shape, the ones that would be consecutively next to each other, like A and B would be consecutive, B and C, C and D, or D and A. Okay? So any of those. So I know like angle B, angle A plus angle B is 1/8. I can say angle B plus angle C equals 180, so on. I could go all the way around. Just the ones that are next to each other. If you listed the letters out in order, like that shape would be parallelogram A, B, C, D. The letters that are next to each other would be consecutive, like A, B, B, C, C, D, D, A, so on. So as long as they're like here, I don't have angles that are next to each other, like nothing's consecutive. These two are across from each other. Same thing with these. These two sides, guys, those are across from each other. As long as they're across from each other, set them equal. So this should be 3x minus 9 equals 2x plus 31. These aren't designed to be extremely hard, guys. Like the actual arithmetic part isn't that difficult. So that should give me x equals how much? It's 31 plus 9.
7.
38.
Yeah, you're close.
31 plus
40.
9.
40.
7.
And then I got 4 plus 5 equals 2y plus 21. So if I subtract 2y, that's that. What's
13.
26. 21 plus 5, right?
No.
No.
Put it on minus 5.
Oh. 16.
And then divide by 2 is?
8.
Okay. The only issue with these sometimes is people, and with this problem here, the 2x plus 10 is meant to be this part. If you're doing the work, guys, you can't see where it's supposed to be pointing towards or going to, because this thing's also very close to that angle. Please ask. Okay, so this is the 2x plus 10's there, the 3x is right there. These two are on a diagonal, it's bisected, so I know they're equal. So I should get x equals 10. 6y plus 10 is on that side, the other one's on that side. Those are opposite each other, correct? Is this part and this part opposite each other?
Yes.
Yeah. Set it equal. So if I solve this out, I get y equals how much?
11.
10, 9, 9.
12.
Kidding, 9.
9.